Hello everyone. This is Rashid Kubria from University of Florida. In my previous presentation, I have extracted the control FSM of the ASCON cipher core from the RTL design that was written in Verilog HDL. In this demo, I will try to analyze the synthesized gate level netlist of that core, more specifically the flattened gate level netlist of ASCON cipher. I will use my developed FSMx-Ultra tool to analyze the gate level netlist and provide us the state transition graph of the control FSM present in the gate level netlist. Here, the main thing that needs to be noted here that FSMx-Ultra is able to extract the hidden don't care states and the don't care state transitions present, which may not be present in the RTL. Of course, that is actually basically absent in the RTL abstraction because many of the state transitions can be detected in the after synthesis in the netlist level, which is not possible to find in RTL abstraction because RTL is kind of so much early design stage. So we may not have many real estate transitions before implementing that or synthesizing that into some hardware. You can find my FSMx-Ultra tool inside this analysis category. If you go to gate, it will show us a couple of tool options we have inside our SSC security tool chain. Here we'll see FSMx, FSMx-Ultra, and some other tools developed by our team. And if I select on FSMx-Ultra, it will again open up a graphical user interface. First, you need to read the technology library in .lib format, and you can find that inside GLFSMx-Ultra folder, here library, and you select the .lib file. And now next you use the same technology library, but in .v format, you add that. That is basically required to perform ATPG-based simulation, which is embedded inside FSMx-Ultra framework. The third task, you have to provide the flattened gate level netlist of the core that you try to analyze. Here I have already synthesized that AES, the ASCON cipher core using Synopsys design compiler, and that synthesized flattened gate level netlist is inside inputs directory. This one is the synthesized netlist file. I hit on open and it will add that. The fourth task, you have to include all the FSM extraction reports generated by RTL FSMx. That was basically extracted from the HDL part. So I add that and I hit open. And finally, I click on extract control FSM button. So it will take a couple of time. And the process will, it will first construct graph representation of the internet list. FSMx-Ultra then performs a structural analysis on that using topological analysis. That means using state-of-the-art efficient graph algorithms. It also measures some metric. Here we see the main FSM extraction part has been already completed, and now it is running the Synopsys tetramesh tool to perform ATPG-based analysis. And here we see we have the process is completed, and it was really very fast. The netlist was used, but it took only like in total within 7 or to 8 seconds, something like that. So here, when the analysis now the graph construction process is going on, so we'll just start a bit, and yeah, you see the window is gone. That means the analysis has been finished. So now you can try to see what result my developed FSMx-Ultra has achieved. So again, I browse through it and go to inside this ASCON AED report. There is actually a convention of this folder, the output folder. The first part underscore report. Before that, the thing you see ASCON underscore AED, that is basically coming from the core netlist file which was being analyzed. In our case, it is ASCON underscore AED.v, which was the synthesized flattened gate level netlist of the ASCON cipher. Now, inside this output folder, you will see three more subfolders. The first one is the netlist directory, and here we will see the extracted control FSM part of the netlist along with the pure combinational state transition logic of that. If you have multiple FSMs, you will see multiple FSMs along with their state transition logic present in this folder, but the name of the folder is always same, that is netlists. And here, if I click on FSM_1.v and hit open, it will show us the extracted control FSM part from the entire netlist. And here we see this control FSM netlist was quite complex. It has so many gates and so many stuffs and all of these things. Now the state register along with the state transition logic. Now, if I recall from the RT analysis page, I think that there were the state register has total 6 flip-flops, and you will see them C state 5. So from 0 to 5, all of these are actually the state register, and the other gates form the pure combinational state transition logic. Similarly, you can also browse for the pure combinational state transition logic, and if you hit open, it will show you only the pure combinational state transition logic part of it. This part was actually modified to perform ADPG-based analysis. So it was converted into an special architecture. You will find the detail in my paper. So I will actually skip that. And now I will show you the extracted state transition graph of this control FSM. So you can find that inside this stg_report folder. And here you see the gate level stg report has been generated in so many formats. So there are basically 3 files. The first one is the text file, the gate level stg, only the states and state transitions, and the verbose. This actually contains not only the state transitions but also the regions for that condition. We will actually get to that. But before that, I want to show you the extracted gate level stg in graphical format. So that is inside this .png file, and if I hit open, it will show us the big state transition graph of this ASCON code. So you see that there are so many states here, so many things, and many of the states are actually having transition to the reset state. The reset state is always shown inside this with this light blue color, and the other states are actually shown in this other format. So this one is the extracted gate level stg of the entire core. We will find not only the states present in the RTL, but also the additional hidden don't care states along with their state transitions. So the control FSM, there was only one FSM in the netlist and also in the RTL design. So that netlist has been extracted successfully by FSMx-Ultra. This really proves the efficacy of FSMx-Ultra, that it can analyze any sort of gate level netlist, either in hierarchical or flattened, and show you the extracted control FSM state transition graph along with their the FSM part of the netlist. So now I will try to show you the state transition graph with the verbosity. So if I select it, it will show us a very big graph, and here it is really a very big file. So just to consider one file for simplicity, let's take this. So here this line in this region, the it1 is actually the from a state type wires, and it is the destination states. So from this, it is actually the primary inputs of the state transition logic, and this one is the primary outputs of the pure combinational state transition logic. And after that, it is actually showing us for which state in which ports you have to apply some sort of inputs to have certain state transitions. Those ports are mentioned here, and those conditions are mentioned here. So there are basically 12 conditions for this sort of state transition from this state to this state. So if you look here at one state, there are total 6 bits. That means our state register was actually of 6-bit wide. And yeah, that is the thing. So we get all the, not only the state transitions, but also the conditions for such state transitions in netlist level. And if you apply these inputs uh, in uh, these wires, then you will have that sort of state transition from from this one to this one. That is all about FSMx-Ultra's efficacy on this ASCON cipher core. And in my later presentations, in the later demos, I will talk about the result of FSMx-Ultra on some other interesting IP cores. Thank you.